Hi all, here's another example of graphing using transformations. This gets into a little bit of a tricky issue. So this is a function we worked at before with our first example. I just want to use it to demonstrate this whole idea of we get into a little bit of extra trouble, or potentially we can get in a little bit of extra trouble if we have horizontal shift combined with any other horizontal transformation. And there's actually two ways you can deal with this. I've chosen one that I think is the least confusing, but you can decide that for yourself. So what I would say is I want to always be able to do things in the same order. So I want to be able to follow this shift last rule. If you want to shift things last, you need to be careful because here what we have happening appears to be a shift right 3. But actually the horizontal stretch that I have going on will mess with that a little bit. So if you're going to shift last, then you need to first do a little bit of factoring to be able to see what the shift really is. Your other option, just to mention it, I won't do it this way, but I'm fine with you doing it this way if you've done it before and you want to stick with it. Just be really careful. You could also leave this and don't factor, but then you would have to shift first and then apply the stretch to the shifted graph. So those are your two choices. Both will work. Factoring out a 1/2 is kind of a weird one. Basically, if you have horizontal shift and then you have anything attached to your x, a division, a multiplication, a negative sign, you have to factor all of that stuff out. So factor out the coefficient of x. Factoring a 1/2 out of an x over 2 is just going to leave you an x. Remember, factoring it out is really dividing it out and putting it out in front. So we're dividing 1/2 by 1/2. If we divide 3 by 1/2, we actually get 3 times 2, which is 6. If that's totally confusing, the easy way to spot if you've done this right is just to distribute it back in. So there's my 1/2 x, which is the same as x over 2, minus 1/2 of 6, which is 3. So for this first one, what I am seeing is a horizontal stretch. And don't be confused by the extra parentheses. This set of parentheses in here is just to separate off the transformations. The key one is still right here. All of this stuff, the 1/2 and the -6, are inside the functions parentheses, so it's all affecting x. So this is horizontal stretch, and this is shift right. Okay, so I'm going to take this graph and make it twice as wide and then move it to the right 6. So it's going to end up a little ways into quadrant 1, quadrant 4, not 1. It's still going to be down below. So quadrants 3 and 4, I think, is what I need to see. Okay, so if I start with -1, 0, I'll use the same points I did last time. Okay, -1, 0. If I do horizontal stretch by 2, it's going to end up at -2, 0. I then need to shift to the right 6. So 1, 2, 3, 4, 5, 6 will end up at 4, 0. Oops, 4, 0. Said it, wrote something else completely. -3, -2. First, we are doubling our x, so it's going to end up at -6, -2. If we then shift to the right, 1, 2, 3, 4, 5, 6, the bottom of our shape ends up at 0, -2. Last, we have -5, 0. So if we double our x, it ends up at -10, 0. Here, I'm going to keep track of this down at the bottom since I don't have room to show that. Okay, so -5, 0. When we double our x, it ends up at -10, 0. If we then shift to the right 6, we're adding 6 to our x, so it'll end up at -4, 0. 2, 3, 4. And that is my other endpoint. So it is now half ellipse. This one's nicely centered on the y-axis. That's the shape that I'm getting. The second one is really just to point out that this is only a problem with x's. So here, if I had done a horizontal stretch by 2 and shifted to the right 3, my picture would not actually be right. here, my transformations are all affecting y. So this is a flip over here. We'll write them in here. Over the x-axis. The multiplying the entire thing by 3 is a vertical stretch. And the adding 1 is a shift up 1. So no horizontal transformations at all, which means we don't have to worry about the factoring thing. No need to factor to get your y values straight. It's only something that affects your x values. So in this case, I'm going to flip upside down, which will put it above the axis. So it'll be the top half of a circle. I'm going to do vertical stretch, which will make it the top half of an ellipse, and then I'm going to shift it up 1. So it'll be vertically stretch out. So it'll be the top half of an ellipse that's sitting up just slightly into quadrant 2. Okay, so make myself some room in quadrant 2. Do we need more than that? Nope, I think that'll be good. Okay, so if I follow some points, I had -1, 0. When I flip over the x-axis, that's going to stay put. It's on the x-axis. It doesn't move when I flip. When I do vertical stretch by 3, I'm stretching away from the x-axis. Still doesn't move if it's on the x-axis. When I shift up 1, that will affect it, so it'll end up at -1, 1. -3, -2. When I flip that point over the x-axis, it'll land at -3, 2. When I do vertical stretch, it'll end up at -3, 6. And then I have to shift it up 1. So it'll land at -3, 7. Again, shifting last, that's going to be the strategy I use. I'm always going to do my shifting last. If in this one you did this vertical stuff after you did your shifting, it could definitely mess up your graph. Okay, and then I had the point -1, 2, 3, 4, 5, 0. I flip over the x-axis. That one stays put. I do vertical stretch. It still stays put. I move up, and that finally moves it to -5, 1. So it's this tall, skinny half ellipse shifted up into quadrant 2. All right, thank you for watching.